Hey guys, I'm Gideon George from Sir Isaac Newton College of Engineering and Technology. Now we are going to see about the orthogonal frequency division modulation. Let's we go. First of all, I would like to give an introduction about OFDM. It is a method of encoding the digital data on multiple carrier frequencies. The OFDM is used in the scheme of digital multiple carrier modulation method. A large number of closely spaced orthogonal subcarrier channels or signals are used to carry the data on several parallel data streams. It can be mainly used in 4G mobile communication. Each subcarrier is modulated with a conventional modulation scheme like quadrature amplitude modulation or phase shift keying at low symbol rate to maintain the total data rate and similar conventional single carrier modulation scheme in the same bandwidth. The primary advantage of the OFDM is over a single carrier scheme is the ability to cope on several channel of conditions. It also uses the predicted technique for fourth generations. The ideal bandwidth also hoping the applications like video conferencing etc. Here the multiple users can access the medium capacity. Then the basic concept of the OFDM, where the narrow band channel have the send the sample using the entire bandwidth, but in the multiple narrow band channels it send the samples concurrently by using the multiple orthogonal subchannels. This is the basic concept of the OFDM. Then why is OFDM is better? Because the multiple subchannels or subcarriers carry the samples and send at the lower rate. Almost it have the some bandwidth with a wideband channels. It has only some of the subchannels are affected by the interface or multipath effect in this OFDM. In the OFDM, we does not use the frequency divisional multiplexing because it have a leakage interference. Due to this leakage interference, the signals which is interferes from the adjacent subchannels. This type of interference can be eliminated by using the guard bits to protect the leakage interference. The need of the guard bits in the bands between the adjacent frequency band, extra overhead and low throughput effect in this OFDM. Then we are going to see about the difference between the OFDM and FDM. This above diagram gives the difference between the FDM and OFDM. In this frequency division multiplexing, the several guard bits are needed to eliminate the interference, but in the orthogonal subcarrier of the OFDM, they do not need any guard bits to these band signals. Then we're going to see about the transmitter and receiver of the OFDM. In the transmitter of the OFDM, the data is supplied to the modulation unit. The modulation unit modulates the carrier signal and message signal, and it is given to the inverse Fourier transform, and the signal is supplied to the digital to analog block. Then the baseband signal of the OFDM is produced and it becomes transmitter, and the transmitter signal can be received by the receiver of the baseband OFDM signal, which is convert the analog digital data into analog data, and then the Fourier transform is taken and the demodulation can be taken and the data will be decrypted from the encrypted transmitter. This is the basic diagram for the transmitter and receiver of the OFDM. Then we are going to see about the frequency selective fading. Here this graph which gives the spectrum of the signal and response of the signals and the spectrum signal defad frequencies. The frequency selective fad is only some subcarrier can be affected. In this frequency selecting, there are the certain number of subcarriers will get affected from this band of signals. Then we are going to see about the ISA. ISA is defined as the inter-symbol interference which is take place in the transmission of signals. The delayed version of the symbol overlap with the adjacent symbols. The one simple solution to avoid these ISA, we introduce the guard bits in the ISA signals, where it can be eliminated the interference caused between this signal. Then we are going to see about the occipital subcarriers. In these occipital subcarriers, the edge subcarriers are more vulnerable to error under the discrete Fourier transform. The frequency must be shifted due to the noise or multipath leave them is unused. In the Ethernet cable, that is 802.11 has only 48 of 60 bits or occupied bits. It is really a worth of OFDM when it is cost so many overhead. Then we are going to see about the synchronization. The digital to analog converters at the transmitter and the analog to digital converter at the receiver never have exactly a sampling period. At the low shift of the symbol timing point which rotates the subcarriers, the intercarrier interference ICI which causes loss of orthogonality of subcarriers. And then the advantages of the OFDM. The main advantage of the OFDM allows the carrier to overlap, resulting in the lesser wasted bandwidth without any intercarrier interference. The high data rate is distributed over the multiple carriers, resulting in the lowest symbol rate. It permits a high data rate as compared to FDM. The increased security and bandwidth efficiency possible using for CDMA to OFDMA. Simple guard intervals make the system more robust to multiple effects. Then we are going to see about the applications of the OFDM. It is an important application to transfer the data from one PC to another PC. The digital audio broadcasting, wireless CD quality sounding transmission, digital video broadcasting, specifically digital terrestrial television broadcasting. It also used in wireless LAN and asymmetric digital subcarrier line, also called DMT, which is defined as digital multitone. Thank you.